Hi, I'm the tech lead, and today I'll be the tech lead. I wanted to talk today about some of the top algorithms to know for the coding interview. I've conducted over 100 interviews for large tech companies, and I've also gone through interviews myself too, so I thought I would share some of my top tips as you're preparing for your interviews. Today we are drinking coffee. I'm taking it black because it is a serious topic, and I'm a serious man. Oh, that tastes so professional. The aroma is just so sophisticated. Now there are a lot of different algorithms to study and to know, but I thought I would key you in on some to focus on especially. One of the top algorithms to know is tree traversal. Tree traversal is used heavily in the industry, and I would be highly surprised if you went through an interview without getting asked at least one tree traversal question. If you think about it, there's not that many tricky algorithms. There's a few you gotta know and that you should know very well, and one of them is tree traversal. So as far as that goes, this involves knowing how to traverse a tree in a number of ways. There's pre-order traversal, in-order traversal, post-order traversal, breadth first search, and depth first search. One common problem is given the view hierarchy where there's a view, subviews, and sub-subviews, traverse every view and print the view. This can be modeled as a tree problem, and you should know how to do it recursively and iteratively. There may also be scenarios where you need to do breadth first search to find the nearest node that matches some criteria. The binary search algorithm also occasionally shows up in interviews where you need to traverse some tree structure looking for some node, and that can be done in logarithmic time. You should also know how to use data structures to represent a tree. In my data structures course, they taught tree structures as having a node with a left node and a right node. But I think that was probably kind of naive because that limits the fanout to 2, and if you want more larger fanouts, then what really makes sense is just having an array. So really all you need to represent a tree is a node with an array of children nodes inside. Now we know that recursion is a common way to traverse these tree structures, but surprisingly a lot of people think they know recursion, but I don't think they know it well, and they don't know it elegantly. And what commonly happens is that when you start writing a recursive function, you start needing to pass parameters to represent state. And then your recursive function gets bigger and bigger, and you start needing to pass a bunch of variables into it. So one thing to think about is commonly recursive programs need helper functions, where you call into the recursive program, and then that recursive program calls straight into the helper function, but passes in a set of initialization variables. That can help keep your code and API clean. You also want to think about what your base case is, because if you can clarify what that base case is, at what point the recursive function will end, that usually helps you write a cleaner function. Recursion is another favorite interview question, and I would be surprised if it weren't asked. Now the thing to know is, commonly in tech, recursion is not actually used all that often because it is limited to stack space. Because of that, recursion has limits and is not that optimal. And usually what professional developers will do is convert that into an iterative function. So this is where you can start looking into gaining extra points. It's good to know that